Hey everyone, welcome back. So we saw from the previous videos that each computer in the internet has its own addresses, which is called the IP address, right? So usually there are two types of addresses at the high level. One is called the public IP and the another one is called as the private IP. So let's today in the video jump into to understand why these two are needed and what are the differences, right? So let's take an example where this is your mobile application. It has its own IP, and then we have a Google server which has its own IP, right? So just to put in this place, Google's IP is usually a public IP and your mobile's IP addresses are usually allocated in the private range. So why do we need these two addresses? So what is the issue with allocating the same type of addresses to all the computers in the internet? So the first issue is security. So here the Google server wants it to be exposed in the internet because a lot of users are using it and Google is getting paid for it. So it makes sense to keep an IP public. That means it is available to everyone in the internet. But then your mobile is a personal thing which you don't want to be exposed to the internet and you want to be hidden from the internet. Say no one can directly hit your mobile phone and get information from your mobile, for example. So you usually keep it as a private. Simple, right? The security part. And the second one is scalability. So usually IP addresses are in the format, say for example, the public addresses might look like, right? For example, so this format falls in the public address range. So say if you take this format and compare with the number of devices that exist in the internet, so you will see that this format will eventually run out, right? So you want to have a mechanism by which you can serve as many devices in the internet, but at the same time not keep on changing this format and keep the scalability in place, right? You understand the scalability part, right? Just to make sure that the addresses are maintainable, right? And the third one is cost. So if you go to purchase an IP address, for example, if Google goes and purchases an public IP address because it wants to expose some service in it, it has to pay to get this IP address, right? Similar to our car numbers, when we want to get a certain car number, we go and pay for it, right? Something similar to that. So these are the three reasons why the concept of public and private came in. If you see the security and cost, this is more related to your mobile phone where security is important and you don't want to keep paying for all the mobile phones, your laptops and everything that you have, which you don't want it to be hit by someone else, but you still want to have internet access, right? So how this works is that, let me take this part, right? And then, so instead of your mobile phone directly exposing it to the Google saying that okay, I am the one calling you, so usually how it works is there is a router provided by maybe your Wi-Fi provider. It can be Spectrum, can be Airtel, right? Router which is provided by your internet service provider, Spectrum or Airtel, and they will be purchasing that public IP. For example, 103.0.113.6. right? So this is a public IP, and when your mobile device usually hits www.com, it always goes to your router, and your router exposes itself to the internet saying, hey, I want www.google.com. It won't say that which device behind your Wi-Fi router actually made the request, right? So it can be your mobile phone, mobile device 1, right? And you might have your laptop here. Laptop 1. So you hit using your Wi-Fi www.com from your laptop or mobile device. Google will only know that the request came from the router. So when you send a request from here www.google.com, it goes to the router, and we know that there is a DNS lookup that is gonna happen here. Google, give me the address of Google. Hey, it is 203.0.113.5. Now the router has the public IP of Google, and it will send the request saying that, hey Google, I want the web page google.com, that is your home page, and I am coming from this IP, which is the IP of the router. So it will never expose your private IP. For example, let's give an IP address, right? 192.168.0.1, and your mobile can have something like, okay, I'll draw it, 192.168.0.2, right? So it will never tell Google whether it came from 68.0.1 or 68.0.2. It will always say that I come from 113.6. So Google will send you the home page to this address, and from your router it will route that request to one of this, right? So we can give a mark like a curly brace. So if your mobile has sent www.google.com, it will send the response back here. If your laptop sent www.google.com, it will send the request here, right? So this part where your router and the mobile device communicates, how the address translation happens from the public IP to the private IP, is usually called NAT, which is address translation, right? So basically the router knows by some logic, which I am not sure as well, that when I get the response back, I need to route it to the laptop, right, which is 0.1. Or if your phone sent, I need to send it back to the phone, right? So just to give an analogy, say this is your house, right, and an ordinary mail comes to you, right? So usually your house number will be 804, for example, and you have a room for your parents, room number 1, and one for your sibling, room number 2, and your room number 3. So usually a mail comes to your house, right? So be it somewhere, it comes to your public number 804, and from there whoever picks it will know that, hey, this mail belongs to my parents. So if you go and pick it up, you know that it needs to be delivered to your parents' home. And if your sibling goes and picks it, and he or she finds that if it is for you, they know that it needs to be routed to 3. So for simplicity, you can say that there is a receptionist or a security guard who is assigned the address 804. So they will pick it up, and they know by some translation logic, in this case it is pretty straightforward, that which room it belongs to, right? So it's like a similar analogy. The only part is I am not sure if you need to pay to get a address, but the other two holds. So whoever is sending you the mail doesn't need to know your room number. So as long as they deliver to 804, it is good for you. And another thing is, if you keep on assigning room numbers for your door number, say there are 20 houses in a row, then you will end up 20 into 5 rooms, somewhere around 100 numbers, right? So here it is more efficient. If there are 20 houses, you can limit it to 20 numbers, and then you have a private number within your property. Yeah, that is pretty much it over here. Yeah, the main part you need to understand is that, so whenever you send a request from your personal device, it always goes to your Wi-Fi router and your address is not exposed to the public. So that is the secure part of it, that no one will be able to know your address and they cannot hit you directly. And the scalability and the cost perspective is also there, but it is not usually that directly related to us, but it is for the maintainability of the addresses. Yeah, that is pretty much it. Let me know if you have any questions in comments, and let's meet in a different topic. Thank you. Bye.